Now let's talk about counting ordered arrangements of n items. So what comes from the multiplication rule of counting is the number of ordered. Notice there's a different word here. We've got order is involved. Arrangements of n items is n times n minus 1. So go down by 1 times n minus 2 times all the way down to 1. This is defined as n factorial. And you may remember that from math. By definition, just keep in mind 0 factorial is not 0, it is 1. And that is definition. We're not going to prove that or show that here. So let's look at this concept through an example. Suppose that we have 4 Giants fans and 4 Dodger fans who are going to sit in a row. So there are a total of 8 seats. And I'm going to use G for Giants and D for Dodgers. In how many ways, in other words, seat configurations, can these 8 people sit? Would you enjoy writing out the sample space and briefly explain why? Well, let's think about it this way. We've got 8 seats. And you're like, well, couldn't I just do 8 times 8 times 8 times 8 times 8? No, that wouldn't make sense because what happens? Let's think about it. The first person chooses their seat. Let's say they choose this seat. How many seats are now left? And hopefully you're like, oh, there's only 7 more choices. So the first person chooses, then the second, third, and then we're going to go all the way down. Hopefully you see that's factorial. That ends up being a big number, 40,320. So my question would be, would you enjoy writing out the sample space? The answer would be no, definitely not. This, just to show, is the same as 8 factorial. Now, in how many ways can they sit so that no Giants fan sits next to another Giants fan? Well, let's think about it. We have 8 seats, and we don't want a Giants fan to sit next to another Giants fan. So we could do a Giant, then a Dodger, Giant, Dodger, Giant, Dodger, Giant, Dodger. And we've got 8 total. Alrighty. Is that the only way that that could happen? You have to think about it. It's like, well, no, what if the first seat was a Dodger fan? And there we go. So how could we write this out? Let's see. There are 4 Giants fans, and the Giant fan, the first one, could choose any of the 4 seats. The same thing would be true for the Dodger fan. But once each of them, let's say they chose these 2, how many are left for each of the subsets? And hopefully you think, oh, well, there's only 3 left for each of them, and then 2, and then 1. This is the same thing as 4 factorial times 4 factorial. This number ends up being a big number. All right, so you can do that in a calculator, but I'm going to show you the total in just a moment. Is it the same calculation for here? Yes. You could either do it this way or do it using factorials. Either way will work. So in other words, you've got 2 different ways that this can happen. So 4 factorial times 4 factorial, and I'm just going to add them together. You could have also multiplied by 2. And you get 1,152. Now, if they chose seats completely at random, meaning that all possible seating arrangements are equally likely, what's the possibility that no Giants fan sits next to another Giants fan? Well, do we remember we have to know the probability of, let's see, no Giant together. We need the size of the sample space, assuming that all outcomes are likely, and we got that in part A. In part B, we found that there were only 2 arrangements so that no Giants fans sat together. And we get 0.029. What's the probability that no Giants fan sits next to a Dodgers fan? Well, we know once again the sample space is 40,320. That's the size. Let's see if we can come up with it. Let's see. If we do all of the giants together. Oh, remember, we're in a row of 8 seats. Can this possibly happen? The answer is no. So the probability is 0.